Hi everyone, I'm Harry. I hope you're all having a lovely time at the conference. So I am just going to talk about the butterfly blues. So this is mapping the distribution of abundance through time of three butterflies I got to study last year as part of the TVERC micro internship, which was a fantastic time. But moving on, let's have a look at the butterflies. So these, as we say, they're all blue butterflies. They actually look quite similar as well. So top left here is the Chalkhill Blue, which I don't want to be sad straight off the bat, but has declined by 50% since 1950. And then next to it is the Adonis Blue, which has dropped by 6% since 1970. And then down there on the bottom left is the Silver-studded Blue, which has taken quite a hit at minus 64% since 1970. Now, so the Chalkhill Blue, it is a high priority species, which means that it requires 50 individuals in a single recording in order to designate a site of protection. It's a small to medium in size, and it enjoys calcareous grassland, and it isn't particularly fussy over food plant. A number of plants will satisfy it, and it enjoys sheltered south-facing hillsides. So these taken together would suggest that maybe, the Chiltern Hills would be the ideal place, which we will come to see later holds out to be true. Now, the next butterfly is the Adonis Blue. This is a brilliantly blue butterfly. It's a similar size to the previous, and it likes dry chalk or limestone grass. It is very much fussier in terms of food plants, so it only goes for the horseshoe vetch. So having quite a niche food plant would make it more liable to decrease in population if that food plant is, endangered by any number of factors. But similarly to the Chalkhill Blue, it likes south-facing hillsides, warmth, but unfortunately, again, it's strongly colonial, and even things like small shrubs, hedgerows, which, are often planted to divide fields, are enough to separate colonies, and it does require grassland turf 1 to 4 centimeters in height. So again, that's quite a niche ecosystem that it requires. So the final butterfly is the silver-studded blue. So this is slightly smaller than the other two, and it inhabits heathland, sand dunes, and limestone grassland. Now around here we're not going to find that many sand dunes, unfortunately. Not really close enough to the beach for that. But it's not very picky about food. There's a wide variety of food it can make use of, and again, like the other two, it enjoys warmth and sheltered south-facing areas. But now I've briefly introduced these butterflies, where actually are they? So in this figure, which was made using QGIS and some really great data layers provided by TVERC, we can see that the Chalkhill Blue is in purple, the Adonis Blue is in blue, and the silver-studded blue is in orange. I thought it'd be a bit confusing if they were all in blue. But yes, let's just have a look in more detail at each one quickly. So this is the high priority Chalkhill Blue. As we can see, they're in two distinct clusters, both on the edge of the Chilterns, but with no actual populations in between these two clusters. Now, it's good that they have set up these quite robust areas, but maybe we should be concerned that there are these wide gaps where high priority population standards are not met. So could this be because, the populations in between these are disparate, or is it because they haven't been recorded and maybe as adequately as these other sites? So next group we look at are the top priority Adonis Blues. So these mirror the Chalkhill Blues really in terms of their distribution, but they do have a greater number of top priority sites. Even there are some even further to the west, which weren't present in the Chalkhill Blue. And then finally, we have the top priority silver-studded blue, where the sites are actually pretty much all far further to the southeast. Now, because they are so close to the border of the area where we have the data, I would suggest that perhaps there are a lot more sites slightly further to the southeast, which would be worth investigating. Just, expand the data set out a little bit, and I'm sure they would appear. So when I was analyzing the recording data and the abundance data for these butterflies, it occurred to me that it might be very important to relate these two ideas and see what the link is between them. So I looked at the distribution of food plant recording. So this isn't the number of actual food plants in any given area, it's just the number of times people have been out to record them. And as we can see in all graphs here, for all food plants, there's strong peaks in the early to mid 1990s. There are also additional peaks in the 1980s, but there isn't a significant bias towards the present. Now, if we look at actually when are we recording our species though, in all cases there are strong peaks towards the present. Now, this could be because people have been more encouraged to go out and record the butterfly numbers, which is fantastic. Additionally, with the Chalkhill Blue, there is a strong peak after 2000 as well. Now, although it's really great that people are going out recording more, biases like this in the number of recordings can lead to some misleading data later on. So if we look at the next, how many butterflies actually are there? So you can see that for Chalkhill Blue, this abundance plot, so the number of actual butterflies there are, strongly mirrors the previous plot of how many times people have been out to record. So again, there's a strong peak just after 2000, and an even stronger one towards the present. And this again is seen for Adonis Blue with a peak after 1990 and another peak towards the present, and the same with the Silver-studded Blue. So really, if we're seeing these really high abundances when we're just going out and measuring more, so there's clearly a link here. I thought that was really worth investigating using some linear modeling techniques. So just to give a brief overview of linear models. So essentially, in a linear model, you have a response variable, and then you have an explanatory variable or variables, and then you have a data source. So essentially, you're trying to see to what extent do the explanatory variables explain what is happening in the response variable. And we're going to look at two numbers for this just for now. So is the p-value. So this is for any explanatory variable, and generally if it falls below 0.05, then the null hypothesis that the explanatory variable is not meaningful to the model is rejected. So we want a really low p-value in order to see whether the explanatory variable is meaningful, but it's not saying to what extent it's meaningful. And then this r² value is the coefficient of determination. So essentially, if it equals 1, then we can say that that explanatory variable explains 100% of the variability in the response variable. It's very unlikely to get a value of 1 though. So let's have a look. So what if we look at a shift to the north? So in this one, we're using northing as a proxy for essentially is our butterfly species shifting north as a response to like climate change or other pressures. And so the explanatory variable is the year of recording, so rec year. And when we look at all of these species, we see that in all cases, the p-value shows that the explanatory variable is significant, but then actually the amount of variability that's explained by it is very low. So the maximum is for the Adonis Blue, which is 7.5%. And so actually the year of recording does not have a huge amount of power in determining how far north we find these butterfly species. So another thing I looked at is the butterfly abundance explained by the number of counts. So this comes back to something we touched on earlier. So we have these counts of how many butterflies there are, and we also have counts of how many times people have been out to look for the butterflies and look for the food plants. Now, I thought earlier there might have been a link between these two, and so for each species I investigated this. So for the Chalkhill Blue, we find that actually if you take both butterfly and food plant counts into as explanatory variables, we find that 81% of variability is accounted for by these two variables. And actually, if you remove food plant count, it's slightly better. So this suggests that the number of times we go out to count the butterflies has a huge effect on the abundance we record. And this is repeated, although slightly lower, for the Adonis Blue. And actually, for the Adonis Blue, there's a pretty much close to 50-50 split in the power of the butterfly count and the food plant count for determining essentially what abundance we're seeing. And so that really tells us that if we go out and measure these things more, then we are inflating the number of butterflies we see. And so it needs to be accounted for when thinking about, how many butterflies are actually around at the moment. And then for the silver-studded blue, this effect is still present, but it's a lot more minor. But the message here is it's so brilliant that people go out and count them, because without all of that information, none of this is possible. But when thinking about statistical models, it's really important to account for biases like this. And the final thing I just looked at was a little species distribution model. So this is really quite basic, and it's something that could be hugely improved on by a future intern, or by anyone who is really interested in this. And I very well could be interested in this in the future. So this first plot is where our plots for the Chalkhill Blue were. So this is just plotted on a very basic background map of the UK. And then if you apply some bioclimatic data through R, you can get a prediction of where, based on that data, the software thinks you should be able to find these butterflies. And so just this scale on the right-hand side of the second image, it's not going to be wholly accurate because there's a lot of model parameters that need to be tuned, but it does give a first kind of pass at where we might look at in the future for either reintroducing some butterflies or going and looking for them more effectively. I think that's a really exciting new way we can look at this kind of data. And I think that really leads on to, it's just going to be a really exciting time ahead. There's so much information here, and I think there's so much can be done with it, and it's of the utmost importance that we protect these species, because without them, so much of the habitat that we all enjoy and we all appreciate and we need will degrade, and it just won't be the same. So thank you so much for listening. If you have any questions or anything, my email is at the bottom of the screen. Yeah, have a lovely day. Goodbye.